The circuit diagram for this one is, so we have a transistor. This is to be used in C mode. The resistance RE, the capacitor CE. Resistance R is used to increase the stability, maintain the stability, and the capacitor CE bypasses, used as a bypass capacitor. Here we have the resistance. This is one of the capacitor. The another resistance. 3 network RC networks are to be used. So here we are using a resistance RC which controls the collector current, and then this has been given to the output. Here we are using the one of the capacitor which decouples the DC. So we call this one as a CO capacitor. This one is the one more capacitor is to be used here. This is a C1, R1, C2, R2, C3 and R3. And here we have a resistance, one of the resistance. Okay, so this one we will, which we will connect to the VCC supply over here. So this is the resistance RB. Okay. So here we are getting the output voltage V4. And here the voltage which is to be supplied to this one will be the VF, feedback voltage, across this base of the transistor. So here we are going to measure the voltage VO, the same voltage which we are getting across this one. This is the circuit diagram to study the phase shift oscillator. Now we are using here 3 RC networks, R1, C1, C2, R2, C3, R3. Okay, and the resistance RB and R3 is providing the voltage divider arrangement, and the RC resistance is to be used to control the collector current. The VCC supply is to be given from this one, and the resistance RE provides the good stability, whereas the CE is to be used for the biasing purposes. So it bypasses, and the output is to be measured across this one. Now we shall see that how that is the circuit is working. As the circuit is to be switched on, turned on, the oscillations are to be set up. These oscillations which are to be set up are just fed through the feedback network, and to this C1, R1, C2, R2. Here we will get a shift of 60 degree. Here we will get a phase shift of 60 degree to another 60 degree, and here we will get the another phase shift of the 60 degree, so that the phase shift, total phase shift of 180 degrees is to be obtained in the waveforms, and this value is to be fed to the transistor, which appears in the form of the amplified form across the collector and shifted by 180 degree. Okay, so 180 degree phase shift is obtained by this RC network, whereas 180 degree phase shift is to be obtained by this transistor properties in the CE mode, and therefore the total phase shift of 360 degrees to be just obtained, and this energy is fed back further to overcome the losses of the tank circuit and the oscillation setup which are of desired, if they are of desired frequency, then we will take the output across this VO, that is the terminal node. Okay, so here the RC resistance RC is to be used to control the collector current, whereas the capacitor CO is just used as a decoupler, that is decouples the DC components so that the output will be purely AC and sustained oscillations are to be obtained from this oscillator. Now, how this the things which we call, that is what is meant by VF, the feedback voltage, what is the VO, and what is the V1, V2, I1, I2. These are the things which we are going to calculate, and the feedback fraction Vf upon Vo, that is Mv is equal to Vf upon Vo will be 1. So these things we are going to know now onwards. Okay, so one by one we will. So here is capacitor C1. This is the resistance R1. Capacitor C2 and the resistor R2 and the capacitor C3 and the resistance R3. So we will call this as node V1, this as node V2, and this as the node VF. Okay, so this we have the VF voltage which is to be obtained across this one. Now applying the Kirchhoff's voltage law at the node V2. Okay, so the value of V2 is to be first of all calculated. So these things we are going to know. Okay, one by one. Okay, the condition A beta, how it is to be equals to 1, how it is to be prepared, that we are going to see. What is VM, what is VO, what is V1, V2, I1, I2, these things we are going to know. So first of all, applying the Kirchhoff's voltage law at the node V2, we will get that is V2 is equal to, it is Vf plus Vc. So if we substitute this Vc, that is this is Vf plus the current, this current which is flowing through this one, say this is I3 current, the current which is flowing through this one is, say this is I2 current, and the current flowing through this network is I1 current. Okay, so this will be given by the I3 divided by j omega c, whereas the value of I3 is to be given by the current which is flowing through this one is to be given in the form of, that is Vf divided by R. So substituting this value of I3 is equal to Vf, call this as one of the equation. So substituting this value in this above one, so the value of V2 is to be obtained as V2 is equal to, this is Vf plus, that is Vf divided by, that is R into j omega c. This is, if you take the Vf to be common out, so that we are left with 1 plus, this is 1 divided by 1 plus 1 divided by j omega rc will be the, that is voltage V2. Okay, one of the term which we have known, that is voltage V2, the value of V2 is to be this one. these things we are going to know about that is the feedback fraction, which is to be given in the form of mv is equal to VO divided by VF divided by VO. That one we are going to calculate beta, and the A beta is equal to 1 criteria, how it is to be fulfilled, that one we are going to see. As applying the Kirchhoff's voltage law at the node V2, okay, at the node this is V2, so that we are obtaining this one as the V2 is to be given by feedback voltage plus the voltage across the collector. The voltage across the collector is to be given as, that is Vf as it is the I3 divided by j omega c, okay, and the I3 as it is to be given as Vf, the voltage feedback divided by the resistance. Substituting this value of I3 here, we get V2 is equal to Vf plus Vf divided by j omega rc. So taking the Vf to be common out, so we are left with, that is V2 is equal to Vf in bracket 1 plus, that is 1 upon j omega rc, right? So now applying the Kirchhoff's current law. So Kirchhoff's current law at the node V2, okay, applying the Kirchhoff's current law at the node V2, we will get the value of I2 to be, that is I2 is equal to, that is V2 by R plus I2, okay. That's I3. The I2 value is to be obtained by V2 divided by R plus I3. Okay. Substituting the values, V2 is known to us, I3 is known to us. Substituting these values in this equation from the equation 1 and 2, so that we will get this I2 to be equals to V2 is, that is Vf divided by R is as it is inside the bracket, that is 1 plus j omega c, 1 upon j omega c, right, rc, and substituting the value of this I3 to be, that is Vf upon R. So from both the terms, the Vf is to be, Vf upon R is to be taken as a common. So we have both the terms as like this, therefore this is Vf upon R is to be taken out, so that we are left with, this is 1 plus, this is as it is 1 upon j omega rc, okay, plus this is 1. So this will be, that is the value of I2 is to be given as, this is Vf divided by R in the bracket, this is 2 plus 1 over j omega rc. Call this as one of the equation, that is equation 3. So we have calculated the value of I2 also. So this one we have calculated, V2 calculated, I2 calculated. So this is the value of I2 from the equation number 3. Okay. So equation 3. And this is the equation 2. Now applying the Kirchhoff's voltage law at the node V1. Okay, the stage third will be applying the Kirchhoff's voltage law at the node V1. We will get the value of V1 to be. So this stage 3, applying Kirchhoff's voltage law at V1. The value of V1. So here we will get the value of V1 is equals to, that is V2 plus, it is I2 divided by j omega c. V2 plus I2 by j omega c. Now V2 value is known to you as we have calculated in the equation number 2, and the value of I2 we have calculated in the equation number 3. Substituting these values from the equation 2 and 3, So that the value of V1 is to be obtained as this is Vf in bracket, that is 1 plus 1 upon j omega Rc plus Vf upon R in bracket 2 plus this is j omega Rc as it is multiple factor j omega Cr in bracket 1 upon j omega Rc. Okay, so we have just substituted the values of V2 and the value of I2, so that now we are just taking the common as j omega Rc. So this is the value of the that is V2 is like this, that is Vf in bracket 1 plus 1 upon j omega Rc, whereas the value of I2 will be Vf upon j omega Rc in bracket 2 plus 1 upon j omega Rc. Now so that this is V1 will be just taking common, that is Vf upon j omega Rc. So if you just solve this bracket, this will be like this. So similarly, if you solve this bracket, this will be like this. So after solving the bracket, taking common Vf upon j omega Rc, okay, taking common Vf upon j omega Rc, so that inside the bracket we are left with this as j omega Rc as it is, multiple factor will be here, right, plus this is Vf upon j omega Rc, we have just taken out common, so that we are left with 1 and plus this Vf upon j omega Rc multiple factor to 2, so we are left with only 2 over here, and Vf upon j omega Rc is a multiple factor to this one, so that we are left with this as 1 upon j omega Rc, right. So now this will be, if we add this together 2 plus 1, it will be 3 j omega Rc plus 1 upon j omega Rc. So this rearranging this one, this equation, so that we will write 3 plus j omega Rc plus this one. So this is 3 plus j omega Rc plus this one will be the value of V1, and call this as equation number, that is 4, right. So we have calculated V2, we have calculated I2, and then we have calculated the value of V1 also. So it is 3 plus Vf upon j omega Rc, 3 plus j omega Rc plus 1 upon j omega Rc. This one we have obtained for the value of V1. Now in the fourth stage, that the Kirchhoff's current law is to be applied at the node V1, so that we will get the value of I1. Applying the Kirchhoff's current law, so at the node V1, this one also we have calculated now, V1. Now Kirchhoff's current law at node V1. Okay, this will be the stage 4th. Now we have calculated V2, I2, V1. Now we are going to calculate the I1. I1 will be, so this is it is I1 will be V1 upon R plus the current, that is I1 plus I2, V1 upon R plus I2, isn't it? At that is Kirchhoff's current law at the node V1, so that we will get the current I2 plus the voltage V1 upon R. So the values are to be substituted. The value of V1 is to be substituted from the equation number 4. The value of I2 is to be substituted from the equation number 3. So that substituting all these values from the 3 and 4, the value of I1 is to be inside the bracket this is 3 plus j omega rc plus 1 over j omega rc is the value of this v1 plus I2 value is to be substituted as, that is Vf upon R inside the bracket, that is 2 plus it is 1 over j omega Rc. So just by substituting the value of V1 and I2, okay, so this will be the equation like this. So now Vf upon R is there, Vf upon R is there in the first term and also in the second term. So taking the common as Vf upon R from both the terms, this is the first term and this is the second term, so that taking Vf upon R is the common, we are left with inside the bracket, this is 3 over this is the multiple factor to this one and is the multiple factor to the another one and is the multiple factor to this one. So 3 upon j omega rc as it is plus j omega rc into j omega rc will, that is divided by j omega rc will get cancelled with each other, so therefore we are left with 1 and this will be multiple factor to this one. Vf upon R is to be already taken common, so that this will be 1 over j square, this is omega square, R square and c square, right? So this is the first term plus, now Vf upon R is to be multiple factor to this one, this is plus 2, this is 1 over j omega. Now this is 1 and this is 2, this will be 3, so that I1 will be, the value of I1 will be, so Vf upon R as it is common to be taken out, term will remain as it is, this 2 plus 1 it will be 3 plus 3 upon j omega rc and 1 upon j omega rc, it will be 4 upon j omega rc and this 1 upon j square will be, the value of j square will be minus 1, so that 1 upon omega square R square c square it will be left as it is, right? So this is the value of the I1 which we have obtained for this question. Now apply the Kirchhoff's voltage law at the node V, at VO, so that VO is to be calculated. This is one of the equations. Okay. So we have obtained the value of I1 to be here. Call this as equation number 4. Okay. Now the Kirchhoff's voltage law at node, apply the Kirchhoff's voltage law at the node V0, so that the value of V0 is to be obtained in the form of, it is V1 plus I1 upon j omega c. So this is V1 plus I1 over j omega c, right? Now substituting the values of V1 from this equation number, that is from equation number 4, V1 value, and this is the equation number 5. Okay. So substituting the value of V1 to be obtained as, this is Vf upon j omega rc inside the bracket, okay, 3 plus j omega rc plus 1 upon j omega rc. This value of V1. So plus I1 is to be substituted from this one and upon j omega rc is remaining active. This is that is Vf upon this j omega R into C, this R is as it is, R into C, and inside the bracket term is 3 plus 4 upon j omega rc minus 1 over omega square r square c square, right? Omega square r square and c square. So this will be the value of the vivo. Now just one thing is to be done here. If we just multiply the things with each other, and Vf upon j omega r is to be taken out common from this both the terms, so that vivo will be, it is Vf upon j omega rc is to be taken as a common. So inside the bracket we are left with, this is 3 plus 3, okay, will be 6 it is, right? And this is j omega rc, and 1 upon j omega rc, 4 upon j omega rc will be 5 upon j omega rc. So this is j omega rc as it is. So this will get cancelled with this one, therefore it will be 1. And then onwards, this is 5 upon j omega rc minus 1 over omega square r square c square is as it is. So this is the term which is to be left with, 6 plus j omega rc plus 5 upon j omega rc minus 1 over omega square r square and c square. Okay, so if we shift this v1 to this side and j omega rc to this side, and the total bracketed term to this side, so that the term will be, that is vf upon vo. Okay, so this will be, the j omega rc will go to the numerator, okay, and divided by, that is this term will be 6 plus j omega rc plus 5 divided by j omega rc minus 1 over omega square r square and c square. This is as it is, the bracket, right? Now if we shift this term to the denominator, total to the denominator upon VO, what we call as a feedback fraction, MV, which is represented in the form of the feedback fraction. So this will be 1 over 6 upon j omega rc plus, this is 1, okay, plus 5 upon, that is j square omega square c square r square, and minus 1 over omega square r square c square. Right? So as it is having no imaginary terms, so that we are left with, that is Vf upon this, either this will go to 0 or the term this 6 upon j omega rc minus 1 upon omega square r square c square will go to 0, or this will go to 0. Therefore this 6 upon j omega rc minus 1 over omega square r square c square, this will go to 0. And if we shift this term to the right hand side, so this will be, that is 6 over j omega rc equal to, that is 1 over omega square r square c square. If we shift this j omega rc to the right hand side, so this will be 6 over, as this is 6 equals to uniform, is equals to, this is j omega rc upon, this is omega square r square and c square, right? So here one j is to be left as it is here with equal factor here, so this is j. So this j omega rc will get cancelled with 1 of the j omega rc, so that we are left with this as equals to 1 over omega square r square and c square. This is equal. So set this omega square to the left hand side and 6 to that side. So this will be omega square is equal to 1 over 6 into r square and c square. So this is the value of omega square, right? So therefore the omega will be given as this is equals to, that is 1 over r into c under root of 6, right? This will be the value of omega, and the frequency of operation which is to be given in the form of omega over 2 pi. So this, substituting this value, we have, this is 1 upon 2 pi rc into under root of 6. If you substitute the value of omega over here, so this will be like this. So in this way, the frequency of operation of the phase shift oscillator is to be calculated as f is equal to 1 over 2 pi rc under root of 6. Okay, so it has that is advantages over the LC oscillators. This phase shift oscillator is having advantages over the LC oscillators, as we are not required, that is in this case we are not required the coils, the inductances L1 and L2. This is to be this is giving the good frequency stability and good sine wave, and also one of the best advantage of this one is that this oscillator can be operated for the low frequency also. With this, that is again it is having some of the drawbacks, that the oscillations that is which are to be set up in the tank circuit are very low, and because the oscillations which are to be set up in the tank circuit are very low, that the output of this one is not good. This is one of the disadvantage of the oscillator. Okay, so the phase shift oscillator we have